everybody. We are now going to start a course on basic electronics. It is essentially a laboratory course. We are living in an age of information technology. Electronics is at the very foundation of the information and computer age in which we are living now presently. The giant strides that we have made in the areas of communication and computers are possible only because of the great successes that we have achieved in the field of electronics. It is sometimes unbelievable how many electronics gadgets that we carry these days in our person. For example, digital wristwatch, calculator, cell phone, digital diary or PDA, digital camera or video camera, etc. The different types of electronic equipment that has invaded our offices and homes these days are also mind-boggling. Many things we use at home and office are remote controlled. For example, the television or the air conditioners, the audio equipment, the telephone. We use a cordless, for example. It is almost close to magic how even a small child nowadays can switch channels or increase or decrease the volume of sound in a TV at home by just clicking on a few buttons at the comfort of a sofa away from the television, apparently without any physical wiring or connection. Again, we are astonished how we are able to talk to our near and dear, living several thousands of kilometers away from wherever we are, at home, office, or on the road in a car or in a classroom, by just clicking on a few numbers on our palm-sized cellular phones. Electronics has thus made deep impact in several vital areas such as healthcare, medical diagnosis and treatment, air and space travel, automobiles, etc. In short, the technological developments of several countries of the globe are directly related to the strengths in electronic design, manufacture, products and services related to electronics. It appears as though that we have to add inevitably an E to the 3 R's that we normally specify to declare a man or woman literate. The 3 R's are reading, writing and arithmetic or arithmetic. Needless to add that the E that I was referring to here means electronics. So apart from reading, writing and arithmetic, one should also have basic knowledge of the E or the electronics. Thus, electronics has become surely a basic science and it is no more an applied science. Just as we teach physics, chemistry, biology and mathematics in our schools, it is time we start teaching our children at school electronics as a separate subject by itself. This brings us to face to face to an important question: how to teach the basic concepts of such an important subject like electronics in the most efficient and effective manner. If one wants to gain a good grip and understanding of electronics, he or she should build circuits and test them independently. For this, one should acquire a practical knowledge of the characteristics of different devices and in constructing the various circuits. Let us try to learn such skills by a proven scheme of learning by doing. What is this? An old Chinese proverb says, I read, I forget. I see, I remember. I do, I understand. So if you need to understand and apply whatever knowledge you acquire, then it has to be by the method of doing rather than reading or seeing. There is only one way to learn to do anything, that is, just do it. That is the way we all have learned as a child even to talk, to walk, to ride a bicycle or whatever. Many arts and special skills like dancing, singing, swimming and martial arts are all learned by going to an expert or a teacher who makes us learn by doing rather than by listening to lectures or reading books. But why learning by doing is so important? It is very simple. The reason is, while doing, we are given an opportunity to fail. So failures are very important in the learning process. Nobody wants to fail, and if one fails, one starts wondering what went wrong. Thus, at the point of failure, there is a profound learning taking place. That is why people say failures are stepping stones to success. Before we go into the subject of electronics, it will be nice to look at some of the background, historical background of electronics. I will just mention to you some few landmarks in the history of electronics. The invention of vacuum tubes or the thermionic valve brought in the age of electronics long time back. Many new and exciting applications were found for these devices. Many great names like Edison, Marconi, Ambrose Fleming, De Forest, etc. are associated with the electronics. As a matter of fact, the transition from the diode to the triode, which has got 3 electrodes, was brought about by an ingenious suggestion by De Forest. He suggested that we can introduce a 3rd electrode in the vacuum tube diode to make it into a triode, and that really brought about a major change and development in the area of electronics. You can see some examples of vacuum tubes on the screen. These are different types of vacuum tubes used for in those days for amplification purposes and things like that. You can see they have a filament which is a thermionic filament. When you pass a current through that, there is thermionic electrons developed which are collected by an electrode which is called the plate, and you have another electrode, the 3rd electrode, which is a control grid, which is in between these 2 electrodes, and any voltage impinged on them will alter the flow of electrons between the 2 electrodes, main electrodes, the cathode and the anode. So that is responsible for the amplification and the such things. Now, after the war in 1948, the transistors were invented in the Bell laboratories in the USA by the 3 great people, Bardeen, Brattain and Shockley, and that brought in much greater miniaturization and applications in the area of radio electronics and things like that. On the screen you can see some of the examples of the transistors. Different types of transistors are shown in the photograph, and the major development in electronics came up with the introduction of integrated circuits. This invention is one of the major development in the area of electronics. Here transistor had become already commonplace in everything from radios to phones to computers, and therefore the manufacturers wanted something even better, something which is much smaller and much more powerful. And two people are associated with the invention of integrated circuits. They are Jack Kilby of Texas Instruments and Robert Noyce of Fairchild Semiconductors. And Jack Kilby was awarded the Nobel Prize in 2000 for his development of integrated circuit. Robert Noyce is no more at the time, and therefore Jack Kilby alone was given for the partial development of the integrated circuit ideas. Integrated circuits can be now found in almost every modern electrical device, such as computers, cars, television sets, CD players, cellular phones, etc. I will show you some photographs of that. The basic idea here is the semiconductors are used for preparing the transistors, but other devices like the resistors and capacitors have to be independently made by discrete methods. It was the idea of Jack Kilby and Noyce whether the same semiconductor can be used to also prepare diodes, resistors and capacitors. Resistors can easily be developed by doping the semiconductor suitably, and the capacitors can be developed by using a p-n junction diode in a reverse bias mode, and therefore diodes can be made, resistors can be made, capacitors can be made out of semiconductor. Therefore Jack Kilby and others thought, why not make the whole circuit, which involves different devices, to be made all completely using semiconductor. That is how the whole idea of integrated circuit came. You integrate the different components like transistors, diodes, resistors and capacitors, all made of basic semiconductor material on the same substrate. See, the bulk resistivity of the semiconductor and its diffusion dope layers could be exploited for fabricating resistors, p-n junction diode, etc. That's I already mentioned. So this is one of the first integrated circuit idea which was implemented by Jack Kilby in his lab. You can see it very crude. It has got no resemblance to the modern well refined design of integrated circuits, which I will show you in the next graph. You can see in this picture one of the integrated circuits, which is a memory chip, is shown here, and the other picture here shows the different integrated circuits. They have different packages. In all of these you can see enormous number of transistors being prepared side by side, and few of resistors and very few capacitors and no inductances at all. So integrated circuits are characterized by very many number of transistors, few resistors, very few capacitors and almost no inductances. So that therefore the whole idea of integrated circuits completely modified the concept of circuit design. Instead of going for the distribution of various devices, in olden days circuits will have more of resistors, capacitors, etc., and less number of active devices like transistors.